Hi, good morning. This is Trina here to discuss about elimination reaction and addition reaction. These are the part of the organic reactions. And in my personal information, I have given the contact number and my email ID. So if you have any doubt, you can communicate with me. And the most important part I have given here, that is the course page. So here I have uploaded all the study materials, the probable questions, all semester questions, and the solved problems. So if, first of all, you have to join with the given code, that is DMBC, then you can access all the study materials. So the subject name, that is chemistry, and the subject code CH101 for odd semester and CH201 for even semester. This course is for undergraduate BTech students and the streams are CSE IT Civil Mechanical for even semester and Electrical EC BAB for odd semester. And the credits 3, contact hours 35. So I will take weekly 3 lectures. And to understand these chemistry classes, the prerequisite knowledge required, that is the 12th standard. And the course objective, the students will learn different concepts of chemistry. So here, along with the course outcome, the lesson plan also given. And in this lesson plan, you can understand that you can have the plan that in each lecture, which topics will be covered. And today, our part is the organic reactions. So this is the module 3. You can see here, the module 3, already I have covered the 2 lectures. The first one was the concept of inductive effect, resonance, and hyperconjugation. The second one was the introduction to reactions involving substitution. And today I am going to tell the addition reactions and elimination reactions. So here it is already highlighted. Okay, so you can look that today I will cover addition reactions and elimination reactions. So from this chapter, the students will understand the basics of organic reactions mechanism. That means how the reactions are taking place, this mechanism they can learn. And also they can predict the different reactions, then what will be the product. After the reacting, if the reagents are given and the conditions are given, they can tell that what will be the product. So this is the outcome. And the textbook is given here, so you can avail it from our library. Okay, now let's start. So first is the elimination reaction. So elimination, from the name, you can understand that we need to eliminate some reagents. An elimination reaction is a type of organic reactions in which 2 substituents are removed from a molecule in either a 1 or 2 step mechanism. The 1 step mechanism is known as E2 reaction and the 2 step mechanism is known as E1 reaction. So this is similar with the SN1 reaction. E1 reaction is the similar with the SN1 reaction and E2 is the similar with the SN2 reactions. So first it is the E1 reaction. So here you can see it is the 2-step reactions. The first step is similar to SN1 reaction, that is the generation of carbocation intermediate. Subsequently, hydrogen is abstracted by the base rather than attack on the carbocation, as in SN1 only one of the substances is involved in the rate determining step, that is unimolecular reaction. So first step is the slow step, so that is the rate determining step. So here what happens, we get the carbocations. So now look at this figure. Here look at this figure, then you will be more clear about the E1 reaction. So here first you can see that bromine beer ion is left. Next, the hydrogen, here the sigma bond between the carbon and hydrogen, that is basically the beta hydrogen. So this hydrogen giving the electrons of this sigma bond to here, and that is why in the product part we are getting the double bond, C double bond C. So first we are getting the carbocation. Here you can see that is the carbocation. First bromine is left, Br minus is left, then it is attacked by the carbocation is formed, hydrogen plus is left, and OH minus is here. Then what happens? So it is the elimination reaction. So this Br minus and H plus left, and this H plus combined with the OH minus, and ultimately the H2O is eliminated. So that it is the elimination reaction. So here basically the attack of base or solvent molecules on the beta hydrogen and subsequent movement of electron pair develops a carbon-carbon double bond. So here we are getting the carbon-carbon double bond, and here the beta hydrogen gives the electrons. So here the sigma bond is broken, and here we are getting the CC double bond. So formation of carbocation is slower process as compared to the reaction between reactive carbocation and a base solvent. Hence, carbocation formation is the rate determining step. So what are the conditions of E1 mechanism? So number one, highly substituted carbon atom for the carbocation center, such as a tertiary carbon atom. So why we are getting the tertiary, that means it is preferable for tertiary carbon, because it is tertiary carbon, because when we do the elimination process, when the mass is huge amount, or the number of persons or number of particles is enough, more than enough. So in a room, say the room size there is like say 4 chairs, and the number of people say 10. So we have to eliminate. So here also the tertiary carbon have more number of methyl group. So that is why we need the elimination reaction. So for tertiary carbon atom, the elimination reaction is preferable. That is the condition. Second thing, the use of polar solvents which can stabilize the resulting carbocation in addition to stabilizing a polar transition state involved in the heterolytic bond cleavage. So in the heterolytic bond cleavage, we use the polar solvent. That is the condition for E1 mechanism. Okay, next come to the E2 elimination. So this reaction involves one step. In other words, no intermediates are involved. It is the bimolecular reaction. Both substrate and nucleophile participate in a single step. The base substrate, the beta hydrogen and leaving group simultaneously leaves such that it forms a multiple bond between alpha and beta carbon atoms. So here you look at the figure, then you can be clear. So it is in the single step. In this single step, the both happens. That means, yes. So look here. Here the hydrogen is leaving and it gives this beta hydrogen is giving the electrons. That is why we are getting the carbon-carbon double bond, and bromine is also left. So it happens in a single step. So it is called the E2 elimination. So here the sequences of events involved are the attack of ethoxide on beta hydrogen and its subtraction as a proton is the first event. Attack of ethoxide, that is the attack of ethoxide, the OH minus, the base on beta hydrogen. So it attacks on beta hydrogen and its abstraction as a proton is the first event. This will leave 2 electrons of the CH bond available for the formation of new double bond. So this hydrogen will give the electrons to make the carbon-carbon double bond. Second, as the new double bond is created, the C-Br bond begin to break away leaving group. This will result in the departure of the bromide ion. So here we are getting the material, that is the HBr left. So in the previous reaction we have seen that is the H2O is left, eliminated, and here we see that means the HBr, this molecule left. So here the bromine is left as the double bond is formed. So you have understood the different types of elimination reactions. Now the addition reactions. So in organic chemistry, an addition reaction is a basic chemical reaction in which 2 or more molecules react to one larger molecule. The addition is the reverse of the elimination reaction. So you can understand from the name, the meaning of this name, that means addition is the reverse of the elimination. So addition reactions are limited to chemical compounds that have multiple bonds, such as molecules with carbon-carbon double bonds or with triple bonds. So if it is unsaturated, what it is telling that if it is saturated like single bond, it is the saturated, so there will be no addition reaction. But if it is either alkene or alkyne, alkene that is the double bond, alkene that is the double bond, and or with triple bond, that is the alkynes. So then only the addition reactions possible. If it is unsaturated carbon, then only addition reactions possible. So molecules containing carbon hetero double bonds may be like carbonyl C double bond O, like cyanide C double bond N groups, then can undergo addition reactions. So as they to have the double bond, that is why the addition reaction is possible. So either there should be the double bond or triple bond, that means the unsaturated carbon. An addition reaction is the reverse of elimination reaction. For instance, the hydration of an alkene to an alcohol is reversed by hydration. So you know this the definitions, like what is electrophile and what is nucleophile. Still again I am telling the definition. It will be easier that you can understand the electrophilic addition. Okay, so a nucleophile is a reactant that provides a pair of electrons to form a new covalent bond. So a electrophile, and what is electrophile? Is a reactant that accepts a pair of electrons to form a new covalent bond. So electrophile accepts pair of electron and the nucleophile provides a pair of electron. So if that is, it provides electron and electrophile that accept a pair of electron. So here the examples of electrophile given, that is the positively charged species like say H plus, NO2 plus, and also electron deficient species like say BF3, AlCl3, etc. And for nucleophiles, the examples given, that is OH minus, Cn minus, H2O, this is the electron rich species, and NH3. Okay, so electrophiles, it accepts electron, nucleophile, it provides electron. Just remember, okay? So now about the electrophilic addition reactions. So electrophiles, like say example HBr, HX, that means it may be HCl. The hydrogen with halogen, HX, X is the halogen. So it may be HBr or HCl, etc. So there it follows two rules. One is Markovnikov rule, another is anti-Markovnikov rule. So this question comes if the alkene is asymmetric. That means it is not the symmetrical. So according to the Markovnikov rules, addition of hydrogen, so where the hydrogen and Br, that means you are getting say HBr. So there is two part, one is H plus, another is X minus or Br minus. Here you can see the, in this example, like it is the HX. Okay, HX. So H, that is the positive part. Okay, H is the positive part and X is the, here you can see, and X is the negative part. So this X will be attached in which carbon and H will be attached in which carbon. That is the concern of the Markovnikov rule and anti-Markovnikov rule. So from this rule we can determine that in which carbon it will be attached. So according to this rule, addition of hydrogen to an unsymmetrical alkene occur at those carbon atoms with maximum number of hydrogen atom. It is carbon with least substitution. Okay, so hydrogen will be added in those carbon with maximum number of hydrogen, and the negatively charged particle like say chlorine ion or bromine ion will be attached with the, so if it is maximum number then it will be attached with the carbon containing minimum number of hydrogen. So let's look at the example, then you can be more clear. So basically the question, which question will be solved by the Markovnikov or anti-Markovnikov rule, that is you are getting the asymmetric alkene. This is the asymmetric alkene because you can see this carbon contains one hydrogen, here is another hydrogen, but this carbon, the second carbon contains, here it is the alkyl group and here it is another hydrogen. So it is not symmetric. It is not symmetric. Now, if it is reacted with say H plus and Br minus, so where the H plus will be attached and where the Br minus will be attached, that is the question. And there is two tendency. First one, you can see that is the hydrogen is attached with the maximum, the carbon containing maximum number of hydrogen. And the second part, the hydrogen is attached with the least number of, that means the carbon containing least number of hydrogen. So what is the correct? So first one is correct. It is the form faster. It is given the stabilized by the inductive effect. Why it is happened so? Because this carbocation is stabilized by inductive effect. You are getting the inductive effect here. Because here is the alkyl group, so it will give the plus I effect here. So it will become stabilized. So this product will be the maximum possibilities of this product. So it will be formed faster. But second one, here it will form slowly because it is not much stabilized. Here is no R group. Here is only hydrogen. Okay, you are clear? And if it is the attached by bromine, so you can understand that bromine is electronegative. Okay, so it will take more electron to itself. So come to the next figure, that is the mechanism of Markovnikov rule mechanism. So there is two possibilities, which one will be correct. So here you can see the first carbon. Okay, just 1 second. Okay, so here this carbon, this is not our concern. Okay, this part is not our concern. We will deal only with the carbon, these two carbon. One contains this carbon and we will consider this carbon. Now, this first carbon contains how many hydrogen? How many hydrogen? Who can tell that how many hydrogen this carbon contains? This carbon contains only one hydrogen. And this carbon contains two hydrogen. Okay. So, which is the number is higher? So, it is the carbon contains the lower number of hydrogen. Here the carbon contains the maximum number of hydrogen. So, as per Markovnikov rules, you know that the hydrogen will be attached with the maximum, with the carbon which contains maximum number of hydrogen. So this hydrogen can be attached with the first carbon or the second carbon, but it will be attached with the carbon having the maximum number of hydrogen. As this carbon has number of 2 hydrogen, so hydrogen will be attached here. Okay, next bromine will be, so bromine will be automatically, as it is the positively charged, that is the carbocation, it will be attached with the positively charged carbon, or you can say the carbon with minimum number of, less number of hydrogen. Okay, so I hope that you are very clear about the mechanism of Markovnikov rules, how the addition reaction take place. So hydrogen, Number A, hydrogen added to 1 degree carbon for more stable carbocation. Bromine added to 2 degree carbocation to give the product. Next is anti-Markovnikov rule. That is just reverse of the Markovnikov rule. So in an addition reaction of a generic electrophile HX to an alkene or alkyne, the hydrogen atom of HX become bonded to the carbon atom that had the least number of hydrogen atom in the starting alkene or alkyne. Peroxide effect. In presence of peroxide for HBr, the reaction will always yield the anti-Markovnikov product. Okay, so if HBr added in presence of H2O2, then it will follow the anti-Markovnikov rule. So see this picture. Here the hydrogen and beer, and you can see this carbon, this carbon contains 1 hydrogen and this carbon contains that 2 hydrogen. Okay. So in first figure you have seen whatever, it will be just reverse of that. In presence of H2O2, it will follow the anti-Markovnikov rule. So all it happens because of stability of the carbocation. So it is like inductive effect, hyperconjugation, all this electronic effect comes here, and the product will take the way that is more stable. So here the hydrogen and bromine. So hydrogen will be attached with the carbon which have the least amount of hydrogen, and bromine will be attached with the carbon which have maximum number of hydrogen. So that is just opposite of Markovnikov rule, that is called anti-Markovnikov rule. So you can understand how this is happening because the stability factor. Here the bromine free radical, we are getting the more stable secondary free radical, and here we are getting the less stable primary free radical. So you have well understood about the Markovnikov rule and about the anti-Markovnikov rule. So these are different examples of the addition reactions. So this is the addition of water. It is called hydration. So it is shown in the different steps. So first, here we are getting the carbocation. Then this step, and ultimately we are getting the product. So that is the addition reactions where some elements are added. So more example we can have, like the addition of dihalide. Okay, that is the chlorine. So here it is the symmetric, everything symmetric. So the double bond will be broken. Double bond will be broken and the chlorine will be added with this. Okay, this is the addition reaction. Next we can show different other types of addition reactions. The example, that is the oxymercuration and demercuration reactions. This is also addition reaction. Okay, so I hope that you have understood the elimination reactions and addition reactions. So if I summarize today's lecture, so you have learned number 1, the elimination reaction En1 and En2 and their mechanism. Next, you have learned the addition reactions and also their mechanism, the Markovnikov rule and anti-Markovnikov rules. Now let's have some question answer, then you can understand that how much you have learned. So first is MCQ. Which of the following is not an electrophile? Which of the following is not an electrophile? Okay. Next is sterically hindered compounds exhibit substitution, elimination, reduction, and oxidation. So first you have learned that elimination reaction, it is the sterically hindered compounds. Why? Because it is if it is like the tertiary carbon, so it is the bulky group, so it will eliminate. That is why the sterically hindered compounds exhibit elimination reaction. Next question, question number 3. Formation of 3-degree stable carbocation is preferred in SN1, SN2, E1, E2. So already you have learned the substitution reaction SN1, SN2, and today you have learned the elimination reaction E1 and E2. So now you can tell that formation of 3-degree stable carbocation is preferred in which reaction? So answer will be SN1 reaction. Next is the reaction with methyl carbon is preferred in which reaction? SN1, SN2, E1 and E2. So it will be SN2. Next, the short answer type questions. The question number 1, write the difference between E1 reactions and E2 reactions. So you can write it very well that what is E1 reaction and what is E2 reaction. So there are two types of E1 reaction and E2 reaction, and the E1 and E2 reaction, one is unimolecular and another is bimolecular. So there is the 2 steps and another is single step. The transition stage, both the elimination takes place. So when you will write the difference, you write in the tabular form and you give the figure of any example. With any example you show the figure that how the mechanism takes place. Next is, why does benzene undergo electrophilic substitution rather than nucleophilic substitution? So what is nucleophile and what is electrophile? You can remember that the nucleophile is the negatively charged species such as OH minus, Cn minus and H2O, NH3. These are the nucleophiles. And electrophiles like say BF3, AlCl3, etc. Okay, so benzene is a planar molecule having delocalized electron above and below the plane of ring. Hence, it is electron rich. So, what will happen? As a result, it is highly attractive to electron deficient species. So, electron deficient species, that is the electrophiles. Okay, that is why what is our question? So therefore we can say it undergoes electrophilic substitution reactions very easily. Nucleophiles are electron rich, hence they are repelled by benzene. Hence benzene undergo nucleophilic substitution with difficulty. So this is the electrophilic substitution reaction. The figure is given. Okay, here you can see the benzene ring, and that is the electrophiles, the positively charged, it is attached with the benzene ring. Okay, so this one is attached with the benzene ring and it replaces the hydrogen. Okay, you are very clear. So for all answer, you try to give the mechanism. Try to give some examples. Then the examiner will be clear that you have the clear conception and will be happy to give the marks. Okay, why phenol is more easily nitrated than benzene? So what is the difference in phenol and the benzene? So there is, in the phenol, there is the OH group, OH functional group, which makes nitrating the molecule easier. Benzene has a delocalized pi system above and below the plane of molecules. The result of this that it is attacked by electrophiles in an electrophilic substitution. Phenol also has this OH group, has an oxygen atom with 2 lone pairs. So one of these lone pair are partially donated or delocalized with benzene's pi system, which increases the electron density across the molecule. This makes phenol more susceptible to attack from electrophiles than benzene. So it is easily nitrated. So you can understand the electron density in phenol is higher than electron density in the benzene. That is why it is more easily attacked by electrophiles, the positively charged. That is why it is easily nitrated. And here all the reactions are given, all the resonating structure also given. So you can mention all these things. So here you can see the how it is nitrated. Okay, NO2 plus. Then this is the structure of phenol, different structure we are getting, and this way we are getting the nitrophenol, that is the orthonitrophenol, and this one is the para-nitrophenol. And this is the only benzene structure. So the electron density less than the phenol. So the nitration of the benzene is also shown here. Okay. So now, what is the next question? Next question is, what do you mean by elimination reaction? So there is nothing to discuss about because throughout my lecture I have discussed. Explain the anti-Markovnikov addition with proper example which came in 18-19 even semester examination. So it is also already I have discussed with lots of example with lots of diagram. So I hope that you are very clear about today's topic. And if you have any doubt, you can contact with me. So today I am ending my session. Thank you everyone.